Hi everyone, welcome to my channel. I will be uploading videos from time to time on my channel on advanced and effective programming techniques in different programming languages like C++, Java, Python, and maybe some more languages. I'll start with a series on C++. Before I start, I would like to make a disclaimer that the videos that I will do as part of the C++ series are intended for people who are already familiar with the basics of programming and C++. So if you are completely new to programming or C++, these videos may not be suitable for you. So let's start. The topic of today's video is the type specifier const. Use const whenever possible. This is a quote by Scott Meyers, and it is taken from his book Effective C++, 3rd edition, item 3. And this is the reason why I have chosen const as the topic of my first video, because it is so important for effective C++ programming. By the way, the book Effective C++ by Scott Meyers is a very popular book in the C++ community. So I would strongly recommend the viewers to read this book. It has 55 items or 55 ways of effective C++ programming. So do read that book. What is const? Const is a type specifier which declares a variable or object as constant. So once a variable or object is declared as constant, it remains constant for the lifetime of the variable or object unless the const qualifier is dropped using const cast. What is const cast and how to effectively use it, I'll explain in a later video. It's not the topic of today's video. Const can be used at global, namespace, file, function, or block scope. It can be used also within classes. For pointers, it is a little bit different story. The pointer could itself be const, or the data it points to could be const, both or neither. So basically there are three cases for using constants with pointers. The first case is with the where the pointer is non-constant but the data it points to is constant. So meaning putter itself can be modified but the data it points to cannot be modified. And there are two representations for this case. Both are equivalent, so you can use either one. The second case is where the pointer is constant but the data it points to is non-constant. So putter itself cannot be modified but the data it points to can be modified. The third case is where pointer as well as the data it points to both are constants. So putter and neither putter nor the data it points to can be modified. Let me show it to you how. So I'm using Compiler Explorer here. Compiler Explorer is a very powerful tool. I will probably explain Compiler Explorer in detail in a later video and show it to you how effective and powerful tool this is. Right now, you just need to understand that it provides a editor and you can program in different languages. So here I have selected C++. And you can use different compilers. I'm using GCC 10.3, but you can also use Clang or Visual Studio. In the upper window, there is showing the assembly language output of the program, and in the lower window, it will show the program once it is executed, the program output once it is executed. So I have defined two integers here and two pointers. So P points to A and Q points to B. Both are non-constants. So if let's say I try to modify Q, or sorry, the memory it points to by giving it a different value, and it will be fine. But if I make Q constant, or then I cannot modify star Q. So it now it gives a compile error that assignment of read-only location star Q This means that now that data or the memory location that q points to cannot be modified. So now q is a pointer to a constant data. We can write it other way around also. It will have the same effect. Yeah. So the second case is where, let's say, now the q itself is constant, but the data it points to is not constant. So now we can modify star q, but we cannot modify q itself. So if I try to assign q to a, it will give an error, a compile time error, that assignment of read-only variable q. And if I make for the third case where q as well as the data it points to both are constants, so now I cannot modify star q and also cannot modify q. So these are the three different cases of using constant with pointers. Let's move to the next topic. So the next topic of today's video is what is const correctness. Const correctness is using const to prevent const objects from getting mutated. Let's assume you want to call a function and the function takes an object as argument. There are three ways you can pass that object as argument: pass by value, pass by reference, or pass by pointer. Pass by value has an implicit cause that a copy of the object is created, and this involves calling the copy constructor. And if the object is big, then means that the cost of creating the copy is also high. This is not the case with pass by reference or pass by pointer. So no new copy is created, and the callee, which is the function being called, works with the caller's object. But it has a side effect that the callee can modify the caller's object without caller knowing. Here I have shown four different cases. So case one, F1 is a pass by reference, so the object is passed by reference. In F2, the object is passed by pointer. In G1, the object is passed by reference to const. And in G2, the object is passed by pointer to const. In F1 and F2, the callee, meaning the functions F1, F2, can modify caller's object. But in G1 and G2, the callee cannot modify the caller's object. So any attempt in G1 and G2 modify the object will lead to a compile error. Let me show it to you how. Okay, so we are here I have defined a variable a, integer variable a, and this variable is passed by pointer to foo. Foo takes a pointer to an integer as an argument. Currently it's empty, and if I print a after the call to the foo, it prints the same value that was assigned to a inside the main function. But let's say if we assign a new value to star num, and star num now points to the same memory location as a, and if we print a here in main, it will print the new value that is assigned to star num, which is the same memory location as a. Here a has been modified. A was defined in main and it has been modified inside foo without any information to main. So if we want to avoid this situation, we have to make this const. And now Any attempt to modify star num or the memory location that num points to will lead to a compile error. So it says that the assignment of the read-only location star num leads to an error. So this is what we term as const correctness. So now num cannot be modified inside the call function. Same is the case with references. So we can do, let's say, so now if we try to assign a new value to a reference to const, then it also leads to a compile error. Moving on, so const correctness is also a form of type safety. What is type safety? I'll probably explain in a later video. For the moment, in the context of const, the type safety means that it prevents inadvertent modification of an object which shouldn't be modified. One good programming practice is to use const correctness from the very beginning, because any addition of the const correctness at a later state of project will lead to a domino effect. Meaning if you want to add const correctness into one function, you may have to add const correctness to many other functions. So any change or any const addition in here will lead to const addition in multiple other places. Let me show it to you how. So let's see. Let, let's say that the foo takes an in reference to num, and there is another function g, and this function also takes a reference to integer. And if instead we make a call to g from f or foo, and we modify here in g, it compiles successfully, and you can see that the value a is now printing the new value, so a new value is printed. But let's assume we want to add const correctness to foo, and we add const here. Now this leads to a error that I was just referencing, that now adding const correctness to foo will not work. You will have to add const correctness to g also. So it says error binding reference to type int ampersand to const int discards qualifier. So you cannot pass a const qualified object or variable to a non-const uh, object or variable. So it means we have to add a const qualifier to G also. And now we cannot modify val. So that's all for today. If you like the video, hit the like button and subscribe, and wait for the next videos. Thank you so much.